Day 14 of 60 in our DSA and Rust challenge. And today we're doing practice problems on strings and hashing. Here's why you should stick around. If you've ever written an anagram checker in Python in 10 seconds and then spent 20 minutes fighting Rust's borrow checker on the exact same problem, today fixes that for good. We're going to see that ownership boundaries and hashing are two sides of the same coin. Both force you to decide who holds what and for how long. Let's get into it. Start with the classic anagram check. Two words are anagrams if they have the same letters in the same counts. The naive instinct from other languages: build a frequency map. So we write fn is underscore anagram. A, str, b, str, bool. Notice both parameters are str, borrowed, not owned. We don't need to take ownership, we're only reading. That single choice means the caller keeps their strings, and we allocate nothing for the inputs. Already, Rust is making us think about ownership before we write a line of logic. Now the counting trick. We make one hash mapture, I32. For every char in A, we do *map.entry c.or_insert 0 plus equals 1. For every char in B, we subtract 1. At the end, if every value is 0, they're anagrams. The key detail: our map key is char, and char is copy. That means the map owns its keys outright. No reference pointing back into the original strings. No lifetime to track. This is why hash mapture I32 just works while your first attempt didn't. Here's the trap everyone hits. You try hash mapster I32 where the str slices point into a string you built inside the function. The compiler stops you. Borrowed value does not live long enough. That's not Rust being annoying, it's correct. The local string gets dropped at the end of the function, so any slice into it would dangle. The error is a lifetime fact, not a design opinion. You have two honest fixes, and choosing between them is the real lesson. Fix 1. Use char keys, which are copy, so there's nothing to outlive. 0 allocation, fastest path. Fix 2. Use string keys by calling .to_string, so the map owns heap allocated copies that live as long as the map does. The trade-off is concrete. Char keys cost nothing but only work per character. String keys cost a heap allocation each, but let you key on whole words that survive the original buffer being dropped. You pick based on whether the data needs to outlive its source. Let's generalize that map into a word frequency counter, the bread and butter interview pattern. Take ASTR corpus, call .split_whitespace, and for each word do map.entry, word, that n_modify, c*c plus equals 1, .or_insert, 1. One pass, no redundant lookups. Entry finds the slot once and either bumps it or inserts. If you want the top word, you can push, count, word, into a binary heap, but the moment you store str words in a structure that escapes the function, the compiler asks for a lifetime annotation. That's the same ownership question wearing a different hat. Final piece, hashing itself, with a Rabin-Karp rolling hash. We treat a substring as a base, 256 polynomial, and keep AU64 hash. As the window slides, we do hash equals hash.wrapping_mul, base.wrapping_add, next_byte, as U64, and subtract the leaving character's contribution. Why wrapping_mul and wrapping_add? Because hash math is supposed to overflow, we want the bits to wrap around the modulus of U64, not panic. In Rust, plain plus panics on overflow in debug builds, so wrapping_add says this overflow is intentional, exactly like how CRC checksums embrace wraparound. That gives O(n) average substring search. Zoom out, and the theme clicks. A Rust hash map forces you to decide, at the type level, who owns the string. Char and string own their data, str borrows, and must be outlived. That's the same explicitness a hash demands about what your data represents. And it's exactly the question interviewers probe in system design. Who holds this? For how long? Master that, and a whole class of borrow errors becomes predictable. Day 14 done. Key takeaway. In Rust, ownership and hashing both reward being explicit. Pick your key type on purpose. Subscribe for day 15.
you.